Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm very excited to be here with Troy Helming, the founder and CEO of EarthGrid. We'll be talking about tunnels.
That's right.
Yeah, tunnels. Specifically, tunnel boring machine Troy has developed that he has described as a robot with lightsabers in the front and a jetpack in the back. I'm pretty stoked to learn more about that. Tunnels and trenches are relevant to climate change because they're an excellent way to transmit clean energy supply to areas of demand. And as we electrify everything, we will have a lot more clean energy to distribute. To introduce Troy quickly is actually a challenge because of how insanely productive he's been in his career and life. But I'll pick some favorite highlights to share here. He's the founder and CEO of two clean energy companies prior to EarthGrid. One was Quaz Energy, founded in 1998, which went on to become the #1 wind energy developer in the US in 2017. In the solar space, he founded Pristine Sun, which has now built solar projects totaling $1 billion in market value. And he invented a system for floating solar farms. He's also an author of a book called Clean Power Revolution and hundreds of articles on topics including clean energy and health and wellness. Outside of his clean energy work, he's a former gymnast and All-American male cheerleader. He's also been on the TV show American Ninja Warrior 4 times. So needless to say, he's a guy with a ton of energy and he's putting that to very good use. Troy, it's really a pleasure to have you on the show. Thanks a lot for joining.
Honored to be here, Dylan.
I just have to say, I love following you on LinkedIn because I get these videos of you doing crazy Ninja Warrior exercises in the gym. And I have to ask, how did that come to be? How does one become a Ninja Warrior?
Well, for me, it was my son, who's now 16, it was 6 years ago, I think, maybe 7 years ago. He saw the show after swim practice on TV, waiting in the lounge for me to come pick him up. And he was telling me about it. So started watching it and we went back on whatever it was, Amazon, or I think it was Amazon, not Netflix, but started watching all the previous seasons, got hooked. And I heard an announcer say, so-and-so is training at a ninja gym. I was like, huh, that's a thing? So I looked up and found a local ninja gym. I was 48 years old at the time. And I had a dad bod. I was pretty out of shape. Like you said, I'd been a gymnast in college and a rock climber off and on, just recreationally for about 30 years. I was like, okay, I'll give this a try. So I went to the local ninja gym and promptly hurt my shoulder and threw out my back and could hardly walk. But it made me mad. And I'm so competitive that I healed up and went back and kept going back and kept going back and just put time in, right? And got in shape and got pretty good. And then started competing in the leagues. And you see the show, people know about the show, but there's even bigger organizations that have tens of thousands of people that compete in obstacle course racing in the leagues. And so I started doing really well, competing against the 20-year-olds in the elite league and pro league, and got to be pretty good. So I was invited to be on the show.
Sweet. So on to clean energy. From your resume, it looks like your passion for clean energy goes back to at least 1997 or 98. And I was looking at this just to try to understand what the context of the energy space was at that time. And it's hard to even find a chart for solar energy growth or wind energy growth that goes back into the 90s. It almost wasn't even a thing back then. So I'm really curious what got you into this space originally and what was the industry like back then?
Yeah, well, it's maybe even scarier, but it goes back to 1980 for me.
Okay.
My dad, I grew up in Kansas City. Both my parents grew up in California, but they moved me to Kansas City when I was 5 years old. And my dad's a successful entrepreneur. He built a solar system on his dream house in 1980. And it was solar thermal. It heated our pool, our hot tub, our water in the house. And then in the wintertime, we'd shut off the pool and it heated the air in the house through these 30 flat plate solar collectors would heat the water and it would go through these preheating copper coils in our furnaces. Anyway, and so one of my chores as a kid growing up was to maintain the propylene glycol in the system and change out filters and pressure relief valves, blah, blah, blah. Anyway, so I've been around solar since 1980, so almost 44 years. But there were no jobs when I got out of business school in clean energy. So I went to work in telecommunications. But in 1996, I started thinking about wind power because Florida Power and Light came to Kansas and started developing a wind farm in western Kansas where it's really, really windy. That's why my hair doesn't lay down, is the wind is so strong. Anyway, and so I started a company in 1998, Trade Wind Energy, that you mentioned, mainly because I read an article. It was a U.S. Department of Energy study, said 3 states could power the whole country with wind: Kansas, Texas, and North Dakota. I was like, why aren't we doing more of this? Florida Power and Light came and did it. We got to do anyway. So I sold my telecom company, started a wind company, made all kinds of mistakes, but eventually figured it out and raised some money and got it going.
What kind of mistakes?
Well, we spent money on things that we didn't need to spend money on. Like we created these beautiful brochures to hand out to landowners and stuff. And we didn't really care about that. We spent whatever it was, like 30 grand on the graphic design and another, whatever, 15 grand or something on printing all these brochures out. I had a trunk full of brochures that I eventually just had to recycle because nobody wanted them. I mean, I handed them out, but anyway, just silly stuff like that. But also thinking that the financial model would be easy. And I had to bring in a consultant who turned out to be my wife, who I just celebrated my 20-year anniversary with her. She was a consultant at Arthur Andersen at the time and was advising Exelon and other energy companies on various things. I was like, hey, I need to build a financial model because I'm thinking this is what it looks like to build a wind farm. I was completely wrong and was giving the wrong idea to investors. And anyway, stuff like that.
Mm-hmm. Well, despite everything you've done with that company and then again in the solar space, I saw a quote from you that said you believe EarthGrid will have the biggest impact on climate change in the economy of anything you've worked on.
Yeah.
I'm curious why that is.
I can say that with conviction because I have felt the pain for decades now developing solar and wind farms. I've felt the pain of the grid. Our antiquated grid in this country is the biggest impediment to the growth of renewable energy. And what I mean by that is 4 out of 5 solar and wind projects that are trying to get permitted and built in this country, 80%, 4 out of 5, die. They get abandoned or canceled before they ever get built. Why? Because it takes them 2 to 5 years to do the studies with the grid operator to connect, and the studies come back, which cost hundreds of thousands of dollars per study, and there's multiple studies. But anyway, studies come back and there's either not enough capacity on the lines or the interconnection costs are so high that it kills the economics of the project. And so I was inspired to start EarthGrid thanks to a Navy SEAL bragging to his girlfriend in a bar when we had to downsize a solar farm by 75% because the grid couldn't handle it. And the cost to go underneath 3 kilometers of protected wetlands and creeks was so high, we couldn't do that. So we had to downsize it. He was a former Navy SEAL. His SEAL team used to practice entering enemy ships underwater by cutting through the side of the ship with a plasma cutting torch.
Okay.
Plate falls in, water rushes in, they go in, pow, pow, pow. You know, we're like, dude, you're a badass. Hope I can say that on your podcast. Anyway, and so middle of the night, I wake up. I'm like, 20,000 degrees. That's hot enough to go through rock, right? Researching, yes, hot enough to vaporize it. Okay, well, surely somebody's already doing this, right? Researching. We couldn't find anybody doing it, but I found some really old papers from Los Alamos National Laboratory in the 1970s where they used plasma on rock and it worked, but there were some issues. And anyway, I just couldn't stop thinking about it. So finally, I took a little money, didn't tell my wife, hired a couple of mechanical engineers, and we tinkered in an industrial warehouse in Oakland, California, and put together a prototype in 2017. I was like, this is either going to be a nothing company or a billion-dollar company. But the prototype came, we got it tweaked, and we punched a hole through a car-sized boulder of granite in minutes. And I was like, yeah, it worked. I was super excited. Anyway, so fast forward to today, where EarthGrid is a telecommunications utility in 43 states, which means we can get access to the rights of way under any public road in any of those 43 states, which represent 96% of the U.S. population and GDP. Basically, we can get the rights of way to put tunnels under any road and put power lines in those tunnels and do it in 1 to 2 years rather than 20 to 25 years that it takes to build an overhead transmission line.
Okay, I need to unpack that a little bit. So as I understand it, you're saying a lot of these kind of new clean energy development projects are kind of dead in the water because of the cost of interconnection. Getting them, you build a bunch of solar panels out somewhere, you've got to run wires from those to where the energy will be used.
Yep.
And you're saying it can take 25 years to run overground power lines relative to a couple years to dig tunnels for those same wires.
That's to put in a new transmission line to free up capacity, correct. So a solar farm doesn't necessarily have to build a transmission line. They just try to connect to the closest power line or the closest substation.
Okay.
But if there's no capacity on that line, then it shuts down the project, right? So then they're stuck and they just park it. It's on the shelf as their inventory. And they hope that someday the utility will upgrade the lines in that area so they can eventually have the capacity to connect. So now we're talking to some of those stuck projects and saying, hey, can we be your extension cord and deliver the power to this factory over here or that data center over there or this corporate campus or this utility substation that does have capacity? Yeah, it's 65 miles away, but we can do it. And they're like, oh my gosh, you solved the problem. Anyway, so we have over 16 contracts signed to do that very thing.
And help me understand, why is it so much easier or cheaper or faster to go underground than over?
Well, typically it's way more expensive to go underground. Historically, it's been anywhere from 7 to 20 times more expensive. So that's why we haven't done it much. Although that's no excuse. Europe, their electric grid is 80% underground. What would you guess the US grid is, percentage-wise? How much of it is underground?
10%.
Oh, wow. I'm impressed. It's about 8, depending on what study you look at, about 8%.
Okay.
8 to 20, depending on the study. Anyway.
I figured it was going to be a lot lower than I would have actually expected.
Yeah. I kind of set up the question. Anyway, but the reason that it takes so long to put overhead lines in here in the US is because what community that you know of would welcome an overhead transmission line going through their community? Right?
Okay.
So projects like the Sunzia line from New Mexico to California, they're officially 19 years in on that project. Unofficially, it's about 23 years. My co-founder at EarthGrid actually worked on that project a decade ago when he was at EDF. Anyway, you can look it up, but these projects just take forever. And it's mainly because they have to get all these environmental permits and the rights of way, and they'll go get private land. And there's no eminent domain law at the federal level that allows a developer to basically take over somebody's land to put a power line there. Probably a good thing, right? Who would want somebody to force big tower, big power line going over your house? But as a result, they have to get people's permission, and it's just very, very difficult.
Are you really talking about a 65-mile tunnel? Or just tunneling through these kind of sensitive areas where there might be a community impacted?
Combination of both. We prefer to do tunneling everywhere. And the reason why is we think for any power line where the voltage is over 21 kV, 21,000 volts, we think that using our technology of using plasma, which runs on just electricity and air, those are our two inputs. And electricity these days is cheap, thanks to the proliferation of solar and wind, right? So we can buy power from the grid, use a mobile substation, connect to the grid, power our machine. We can bore it 1 kilometer per day. And for 21 kV or higher, we can put a power line in at the same cost or less as what it would be overhead. But the permitting and rights of way, again, we can get that taken care of in less than a year versus 20 years for overhead.
Mm-hmm. Well, and I imagine there must be other benefits of being underground. I'm just thinking about like all the issues in California with power lines and fires.
Absolutely. For sure. It's fires, it's ice storms. Like I just heard this morning, I was talking to the Economic Development Group in the state of Ohio, and they were saying that there was a really bad ice storm this last winter, and the guy's parents were out of power for 10 days. The average in the state was like 3 to 5 days just because of ice storms. That was a tornado, but they also had a really bad ice storm. Hurricanes, earthquakes, you name it, anything, even traffic accidents and squirrels take power lines out all the time, every day. And so putting it underground makes the grid 9 times more reliable with 10 times fewer truck rolls. So it's actually much better for our electric bills. ratepayers if the utility isn't charging us every time they have to go inspect the line because of an ice storm.
And so Europe is doing a bunch of tunneling, it sounds like. What technology are they using? What's the kind of state of the art for tunnel boring prior to your plasma innovation?
Yeah, they're using the same technology that we're using here in the US, which is horizontal directional drilling, sometimes trenching. And trenching is just digging a ditch. If it's dirt, that's easy. But if there's rock under the dirt, it's hard. You have to use either rock saws or jackhammers or dynamite. Can't use dynamite in a lot of areas because it'll shatter windows and nobody likes it anyway. And then horizontal directional drilling uses the drill bit, right? And they, depending on whether it's hard rock or medium rock, they might have to change out the drill bit 5, 10, 20 times a day. Plus they use lubricants, chemicals, bentonite, drilling mud, all that stuff, which leaches into the groundwater, collect as much as they can, but then they have to pay to truck all that millions of gallons of wastewater to a water disposal, water treatment facility. Anyway, it's just very, very costly and bad for the environment. Whereas we're just using plasma to cause the rock to turn into sand and gravel. We vacuum it out, and then we sell the gravel for road base and sell the sand for concrete manufacturing.
And it's just plasma kind of melting and vaporizing and I guess breaking down whatever's in its path, essentially.
Yeah, I can share a 20-second video if you want.
Yeah, let's put a clip for folks to see in the show notes. And I was going to ask about that too. Is there a challenge in getting all the kind of debris out of the tunnel? And how does that work?
Yeah, talking about making mistakes at every company that I've been at. And by the way, EarthGrid's company number 8 for me. So I've had 1 failure, 6 exits, and 4 of the exits were meaningful and 2 of the companies were unicorns. But so every company have failures. One of the failures is we're like, oh gosh, we're boring through sandstone or basalt and we're creating all this magma, man-made lava. And we're like, how in the world are we going to get that stuff out? So we're like, well, let's try a vacuum. So we go to Home Depot and buy 6 vacuums, hook them up in parallel, and we suck everything out. And it sucked out the lava. And 3 seconds later, it was all melted. All the hoses were completely destroyed.
Yeah.
So, okay, well, that kind of worked. So many, many iterations later, we now have an industrial mining vacuum that has a water-cooled sleeve on the inlet. So it cools the magma and we suck it out when it's still really hot and runny before it gets too viscous. And it turns it into silica sand, which is actually a valuable commodity. There's a global shortage of sharp sand for concrete manufacturing. Sand on a beach doesn't work. It's round because it's been beat up by the waves. So the machine that we have, I mean, mines are incredible. If any of your listeners have been to a mine, but we use a mining vacuum that can pull a big pile of gravel, like the size of a car, size of a pile. It can pull that 8 kilometers distance in one shot, and it can do it in about 5 minutes.
Wow.
It's incredible. Now, it takes a huge air compressor at the surface to run the thing, but we've been testing that big bad boy vacuum about 10 minutes from where I'm sitting here at a land owned by a Native American tribe where we bored a 2.5 meter diameter, 8-foot diameter tunnel into a cliffside.
Wow. Okay. So you would have these kind of inlets at a maximum of every 8 kilometers so that you can sort of be continuously sucking out the magma.
Yeah, either that or put multiple vacuums in and stage them, one every 6 to 8 kilometers. And they kind of move down the tunnel or whatever as we go because they're on wheeled skids. So,
okay. So it actually is, you're turning everything into magma, this sort of molten rock, and then it's cooling. And that's where you get the sand and gravel. Is the cooled magma?
Yes and no. So depending on the geology, we have about 1,350 trade secrets we've accumulated over the last 7 years. And what I mean by that is mostly those are our recipes for each kind of rock. So the magma only happens in high silica rock. So things like sandstone and most basalt, some granite, depends on the geology. But what happens with the plasma operating at 6,000 to 27,000 degrees is it's not just the thermal energy, which, yeah, it's insane. I know. Really does feel like Star Wars. And by the way, my son helped me with the Star Wars analogy. He's a fan. But anyway, so the rock will either spallate, which means it turns into gravel or sand.
Okay.
And that's mostly what happens with like limestone, the most common rock under continents, and shale. It's mostly like sand and gravel. Or it'll turn into magma, like we've already talked about. And then the third possibility is it will literally just vaporize, which means the rock turns to vapor. And then the vapor will cool and precipitate or rain into silt. all of that can be picked up by the vacuum.
Is there any way to like wrap your head around what 27,000 degrees? Are we talking, is this talking Celsius?
Celsius, yeah.
Yeah, 27,000 degrees Celsius. What does that even mean?
I mean, plasma is what the sun is. It's a big ball of plasma.
Right.
Plasma is the fourth state of matter, right? Solid, liquid, gas, plasma. So that's not new. Plasma has been around a long time. We're just applying it to this use case of using it for creating underground construction.
Tell me about that first prototype you made in 2017. Could you go to buy welding equipment and hack this thing together, or what did that look like?
Yeah, we did. McMaster car, lots of different parts to create a little miniature track that it would go into the boulder. It was a small plasma torch, small by my standards, I guess, meaning it was 125 kilowatts of power, which is what? It uses the same amount of power as what 30 houses would use.
Mm-hmm.
So it's, I guess, a lot. But when I've been building megawatt class, hundreds of megawatt solar and wind farms for decades, it seems small. But anyway, and now we're using, so that was 125 kilowatts. Now we're using 1,500 to 5,000 kilowatt torches, megawatt class torches. So it does use a lot of power, but you can draw it from the grid. And tunnel boring machine also uses 10 to 20 megawatts of power. And our 2.5 meter machine needs about 8 megawatts of power. So it's actually a little less than a big tunnel boring machine. But the first prototype, it was really basic. It only moved in one direction, forward and backward. It didn't go in the X or Y or Z axis. It was anyway, excuse me, I guess that's the X axis, but well, depending on how you look at it. But it just went straight through. And then we started adding articulation to it. And then I'm very excited to announce that in 2 weeks, for the first time ever, no one in the world has ever put multiple plasma torches on rock, and including us. We've only been using one torch at a time. Our 6-torch system, most of the equipment will arrive in the next couple of weeks, and we're going to be punching a hole with 6 plasma torches at once.
Oh, sweet.
So depending on the rock type and the torch spacing, it'll get us like a 1.5 meter diameter, which is what, 4.5 feet. I do everything in metrics. Thanks to pirates, the U.S. still is the only country in the world that doesn't use metrics.
Mm-hmm.
Anyway, and then we're going to have a 9-torch system. Hopefully late summer, there will be about a 2 meter diameter, which is a little more than 6 feet.
Okay. And does that just open up just more of the market? I mean, do you need more transmission lines through the same tunnel kind of thing?
That's right. And some of our utility customers, solar and wind developers, have said, hey, if the tunnel's big enough for people to walk in it, we would prefer that if the cost isn't that much more, because then they can repair splices in the cables or visually inspect the lines, add fiber, add water, add other infrastructure to the tunnel. So it's more future-proof. There's other use cases, like even we have agreements signed with 3 robotics companies that want to move our Amazon packages using robots going through like 18-inch tubes. So we'll put those tubes on our tunnels as well.
Nice. So this is about, 7 years ago, you made that first prototype. What's been happening over the last 7 years? Has a lot of that been time devoted to engineering and developing further the tunnel boring robot?
Yeah, that, but also about 4 years ago, I came up with this idea to get access to the rights of way. So I talked to a former commissioner at the California Public Utilities Commission, Rochelle Chong. She's also a former federal regulator. She was a commissioner at the FCC, the Federal Communications Commission. And I was like, hey, if we become a utility, either telecommunications or electric utility, would we get preferred access for the rights of way on public roads? And she's like, yeah, for sure. So we back and forth. Anyway, we came up with that process. But that started about 4 years ago, maybe 5 years ago now. And EarthGrid is now, I think I may have mentioned this, but we're now approved as a utility in 43 states to give us preferred right-of-way. So a lot of R&D, a lot of engineering, the utility status, and then also working on our business model and customers and insurance and bonding and all the things that we know we're going to need to do to go out to the marketplace. But we built our MVP, our minimum viable product, last summer, a plasma excavator with 1 torch on it, and made money with customer projects for the first time last year. So
nice. And I do want to get into the business model a bit. Before that, though, I'd love to hear more about that kind of development process, the R&D process. What have been some of the big challenges you're facing in getting from that very first kind of hack together prototype to an MVP?
Yeah, so three things. Spoils removal, which we talked about, and the magma, figuring that out took a while. The tunnel lining, the reason why that was important is our process. We think we can go at speeds of up to 1 kilometer per day, 1,000 meters a day. The world record for a tunnel boring machine is 47 meters in one day. That was established in Turkey a couple of years ago.
Oh, wow.
Yeah,
That's a big move.
it's a bit, yeah, right. The average is like 20 or 30 meters a day. And we've demonstrated we measure in millimeters per minute. But if you extrapolate that out, we've measured that we can go at speeds of 500 to 1,000 meters a day. So, how do we line the tunnel? Now, there's hundreds, maybe thousands of tunnels around the world that have no concrete lining at all because they don't need it because they're in really hard rock. I went hiking in the California mountains, an old train tunnel with my family last summer in one. There's literally no concrete. Having said that, even in hard rock, you want to line the tunnel, right? Because you can get water seeping in. There's an earthquake, you might get little chips. Even in really hard rock like granite, you might get chips that fall down. But nobody has any technology that can keep up with that speed of 1 kilometer per day. So that took a while, and we didn't come up with that ourselves. What we did is, because we're a startup, we have limited resources. We partnered with, we believe, one of the world's best shotcrete and concrete spraying companies, and they developed some IP together with us that can keep up with our speed to line the tunnel.
So is that another robot that follows your robot?
It is. We call it a paving tractor, but yeah, it's another robot that comes immediately behind with 3 arms that spray the shotcrete concrete mixture with seismic and waterproof polymers or fibers in the mixture with a really strong adhesive so it sticks to the ceiling and the walls.
Yeah, so cool. What about on the kind of plasma side of it, the dangerous end of it? What's been going on R&D wise there?
Yeah, cooling is another big issue, obviously, these temperatures. And so the cooling load is about 40% of our energy consumption, just keeping the robot, the plasma torches and the robot cool, because magma is dripping all over these things. It's kind of fun to see, and we do live demonstrations for customers and investors and even the public sometimes. So ping us if you want to come see it in action. But
yes,
yeah, the cooling load was heavy. So we started with evaporative chillers. That didn't work. We could only operate for initially like 45 minutes at a time, and things would start to overheat, and the O-rings inside the plasma torch would melt. They weren't exposed directly, but the temperature just got so we slipped.
Yeah.
We went to Viton, and anyway, tried a bunch of things, but we just had to upsize to a beefy 500-ton HVAC chiller, which is on a trailer at the surface to cool the torch.
I was going to ask, because you have to dump that heat somewhere. So do you have coolant lines that run all the way back out to your kind of,
that's right,
wherever your vacuum is and everything?
It's a closed loop. Yeah. So we don't consume water, but we have the supply water that goes out that's really cold at I think it's typically about 12 to 14 degrees C. And then it comes back typically 10 degrees C hotter on the return line, runs through the chiller, cools it, and then keeps recirculating.
I mean, it sounds like a really complicated product. Where do you see kind of the next set of challenges for that from an engineering standpoint? What's still left to risk mitigate, or is it more about expanding the product line or new features, that kind of thing?
Yeah, we don't think there's any significant risks. There's no physics challenges, but there's known unknowns. And then of course there's unknown unknowns that we'll have to figure out, but they're just going to be engineering challenges from this point forward. But I'll give you an example of one of the known unknowns. I alluded to it earlier, and that is torch spacing. Because no one's ever put multiple torches on rock, we've done a bunch of simulations in ANSYS, our desktop simulation, with 6 torches. We know the kind of vortices and the CFD work that we've done. We think we know what the torch spacing is, but we've got to test it out in real life, right? And also in different types of rock and see if there's a difference in torch spacing to optimize. The plume of each torch it creates a whole 2.5 times the surface area of the torch itself, which is nice. But we don't think the plumes have to touch or even overlap. We think they can be separated a bit because of the synergy between multiple torch plumes. But we have to refine that. So we're mounting 6 torches on what we're calling a nibbler. It'll nibble into the rock and go a couple of meters in and do 3D scanning before and after and all the sensors and everything, and do that 100 times on lots of different types of rock and soil. And then that will hopefully allow us to come up with not only a database to to inform our process in real time as we go to modify some of the variables other than the torch spacing. Like, for example, airflow. More airflow means the plume is more narrow, but deeper, right? And if we reduce the airflow, it expands. And so we have a little bit of flexibility to modify our speed and our diameter by changing the airflow. Without getting into trade secrets, there's a few others as well. But anyway, those are the kinds of things we need to do over the next several months.
Oh man, I could nerd out on this for a while. This is like super interesting. One thing I was curious about. So I think it was episode number 5. We talked to Carlos Araque from Quaz Energy. I don't know if you know these guys, but they're doing geothermal drilling using millimeter wave. So they're
millimeter. Yeah, I know Carlos. Yeah, great work they're doing.
Okay. They're vaporizing rock with RF energy instead of heat or instead of plasma. Any pros and cons of an approach like that? Have you considered that instead of plasma?
Yeah, we considered that. We considered laser, but we felt like the ability to go cheap and fast using kind of off-the-shelf tech and using with modifications and then using electricity, we feel like we're going to potentially have a better use case for boring, tunneling and boring. For vertical, what Carlos is working on, and I think he's got a great technology and a great company, and I'm cheering from him. For going vertical, I think his tech's probably better than ours. And there's a few reasons for that, but time will tell. We're both kind of at similar stages of tech development. And I think there's room for 100 companies out there doing this kind of work to improve the speed of digging and boring, whether it's terrestrial applications or applications for asteroid mining or habitations on the moon or Mars or whatever. We're going to need energetic drilling and boring rather than mechanical. We need to move beyond mechanical to energetic use cases. So let's put it all out there. Some projects will be better with millimeter wave. Some will be better with plasma. Some could work with either one. But the more tools we have in our tool belt that use cheap renewable energy, the better.
Let's talk about the business model. You mentioned this earlier. What are you selling and who are your customers?
So we're not going to ever sell our machines. That's kind of a race to the bottom if we're a hardware sales company, potentially. Maybe, maybe not, but that's just not something we want to do. Most importantly, we don't want to let people figure out our trade secrets, our recipes for the kind of rock. We want to protect that. So we have 2 products, and they're called Boom and Badass. Got to have a sense of humor. Boom stands for build, own, operate, and maintain, and Badass stands for boring and drilling as a simple service.
Okay. So in one, EarthGrid is building, owning, operating, and maintaining the tunnels.
Correct.
Okay.
Exactly.
And then the other, somebody will hire you to bore a tunnel for them, and then they take over ownership of the tunnel.
Exactly. And they'll pay us like per cubic meter of material removed based on the location, the length, the diameter, the type of geology. And we can go through anything. Even we accidentally cut through carbon steel I-beams that were supporting one of our test beds.
Oops.
Yeah, we can go through Big Bertha in Seattle. The tunnel boring machine got stuck for like more than a year because of some metal pipes that nobody knew they were there. It got tangled up in the cutting head. We would just go right through it.
Yeah, you could just bore right through Big Bertha and just keep going. Probably.
That's right. Yeah, exactly.
Okay. And are these then going to be utilities, or who's actually buying tunnels as a service from you?
Yeah, so the projects we have right now that are the tunnels as a service or BAS or Badass or whatever you want to call it are, primarily utilities where they want to own the tunnel. And also we've done a little work with U.S. Department of Defense, initial project with the Air Force, and some more more discussions are ongoing. So there may be some applications there where they want to own it, which is fine. We'll make good margins, 35 to 65% margins minimum on providing that service.
Thinking about the future, what kind of impact do you think EarthGrid can have on the industry? What does success look like, and what kind of time frame are you looking at for that?
So there's a number of industries that potentially can be affected by our tech. It's not just the tunnel boring industry or construction. It's also, we've talked about power and fiber and water, transportation, whether it's 2 or 3 lane highways that we're tunneling or train, subway, whatever. But to me, what success looks like is, back to my book, Clean Power Revolution. Please, nobody buy it because it'll put you right to sleep. But I wrote it 20 years ago. I said that we need 270 new transmission lines to unlock all this cheap solar and wind power to make the grid clean and cheaper. cheaper electricity for all of us. And it's just not happened. I think we've built 2 regional transmission lines in the last 20 years. So that's what success looks like to me. And with the 16 contracts we have already signed and about another 12 or 15 that are in various stages of negotiation, if that's all we do as a company in our lifetimes at EarthGrid, if that's all we do, it will enable close to 100 gigawatts of new renewable energy coming onto the grid years, in some cases decades faster than it otherwise would have.
Yeah. It's crazy to think about that, but I've heard similar things that like there are so many undeveloped clean energy projects in the world right now. Something like more capacity that we have currently active is waiting through this kind of permitting and
That's right.
interconnect approval process, whatever it is. So I guess at a really high level, you're enabling that to be, or EarthGrid is enabling the acceleration of all of that.
That's right. Exactly. Yeah. Whether it's a gen tie, like I said earlier, connecting a solar or a wind farm to a data center or a factory, or whether it's working with a utility that is getting bombarded with requests from the, 400 new factories that the Biden administration has approved or passed funding or whatever for in the infrastructure bill and some of the other bills, and some of the work done even when George Bush was in office, the ARA program. Anyway, there's so much happening that is increasing demand for electricity that utilities can't keep up. So some utilities are saying, hey, give you an example, the LA basin. There are many, many utilities in LA, whether it's Burbank, Anaheim, LADWP, as well as Edison and others, San Diego Gas and Electric, Sempra, that there's not enough transmission capacity into Southern California or the Bay Area for that matter to meet the goals of some of the Hollywood studios or data centers or factories or whatever that are trying to meet their ESG goals. Yeah, sure. But more importantly, they're trying to save money, right? And solar is by far the cheapest form of new energy generation globally. Wind is, solar and wind. It depends on, I won't get too deep on that, but solar or wind, and there's just no way to do it. So some of those utilities have talked to EarthGrid about, hey, can you bring in a new transmission line from Mojave or Imperial County to the coast? And we're like, sure, because their customers are clamoring for more green energy and they just can't get it.
What about all of the, you hear so much now about how AI is going to create all this new demand for energy and these new remote centers that need to be connected to the grid. Is that a trend you're following, and is that relevant here?
Absolutely. Yeah, I attended the Metro Connect conference a couple of weeks ago in Florida with Katie, our vice president of business development. And yeah, so many data center developers, the big names that people know of, as well as names that are not household names, the hyperscalers and others. And yeah, the demand is so high. They're telling us that their host utility where they're developing these data centers and trying to build, used to tell them, yeah, we can get you the power in 18 months or so. We'll get it to you. Then it was 2 years. Then it was 3. Then it was 5. And now it's just no. Utilities are just saying, no, we have no solution for you. So don't build any more in our area.
So the other trend I hear a lot about is kind of the distributed grid or microgrid, or where you have rooftop solar or like small clean energy production distributed around. Does that reduce the need for tunneling in the way we've been talking about?
It does not, unfortunately. I have solar on my house. I've had solar on pretty much every house I've lived in since 1980. If we were to put solar on literally every rooftop of every building in America, homes, schools, churches, businesses, everything, what percentage would you say that would power of our electric needs today?
Oh man, I nailed the question last time. Now I feel like the pressure's so high.
Put you on the spot here.
20.
You're right.
On every rooftop, 20%. Yes.
Yeah, you're right. It's around 20, 25%, depending on the efficiency of the solar panels that you put on there. So we need centralized solar and wind. There's just no way to avoid it. And that's to meet today's energy demand. But when you start looking at the electrification of everything, electric vehicles, heating, for instance, in our home, my wife has asthma. And so every time I would cook, I'm the one that cooks most often in our home, in natural gas stove, right? And I always loved natural gas stoves, but she would always have to use her inhaler. And we saw this article recently that if you cook with natural gas, it's equivalent to having a smoker standing in the room with you. So I was like, okay, well, we got rid of that, replaced it with a GE Cafe induction stove, which is way faster than natural gas. I love it. But we put a heat pump in. And anyway, we're all electric in our house. Other people are doing this too, right? So the electrification of everything is going to double or triple the electric demand. And then if you look at AI, like you were just talking about, that can triple it again. So now rooftop solar, instead of 25%, maybe it's only 5% ish. So we've got to have big centralized solar and wind, which you can build at a much lower cost, much more efficient. So there's no way to avoid it.
And maybe this is a naive question, but as everything becomes electrified and the demand in a certain metropolitan area or something increases, are we just talking about new interconnection between kind of new solar and wind developments and those centers? Or is there existing infrastructure that needs to be upgraded because we're transmitting a lot more power over old existing lines? Does that make sense?
Yeah, it does make sense. It's some of both, but it's mostly just the new lines. Like, for instance, there are a lot of really beefy for lack of a better word, the technical term, beefy substations in cities and load centers that just need to have a better transmission line connected to it. And so whether it's underground coming right to it, or it's underground going to the next substation in the line and injecting there with maybe some modest upgrades in between those two. There's a variety of ways to accomplish it, but it's primarily our electric grid in the US is by some measures the largest machine ever built in the world, but it was never designed. It evolved. Had we designed it from scratch, we would have done it very differently, but it evolved in a patchwork and fragmented. And there's all these weird things like there's three grids, the Eastern grid, the Western grid, and Texas, because Texas might want to succeed from the nation at any moment, right? So they have to have their own grid. So anyway, and there's very few interconnections between the two. So we can't solve problems in the Texas grid by sending this huge amount of solar power we're generating in California. We can't send it to Texas and vice versa. Texas is the leading state for wind power, and they can't send it to California when we have our peak in the evening. Anyway, there's a lot of upgrades that need to be made just on transmission and use a lot of the existing infrastructure.
Okay, I have two questions to close out. The first is, what is another company or individual doing something to address climate change that's inspiring you?
Okay, that was easy. Company, I would say Tesla. I'm not going to speak about Elon. I used to be a really big fan of Elon. Now I'm not as big of a fan. I still love what he's done. I mean, Tesla literally changed the world, right? I mean, it literally changed the world. It has made EVs fun, exciting to drive, affordable, and basically forced every other car maker in the world to adopt EVs. So to me, that comes to mind first. By the way, I bought stock at the Tesla IPO. I just picked up my Cybertruck Beast Mode Foundation Series yesterday, the tri-motor, and it's my fourth Tesla. I bought a Model S 12 years ago. Anyway, that's one. There's others, but I'll pause there.
Yeah, Elon gets a number of shout outs on the show, actually. And I think it's okay to appreciate what he's done, even if you don't totally agree with all his other decisions. What advice do you have for someone not working in climate today who wants to do something to help?
Well, first of all, make sure it's your passion. The thing that has, I think, helped me more than anything else in my career is that I try to do things, even though it might sound crazy and it might seem risky, I try to do things that get me up in the morning. The power of purpose means so much more than whether you have domain expertise or knowledge or experience in that area. If you're passionate about it, you'll figure all that other stuff out. So I'll start with that. Make sure it is in fact a passion. Then the second thing is decide whether you want to be on the technical side, engineering. If you're young in your career and going to school, engineering, there's going to be a need for a huge amount of additional engineers in the climate tech space. So either going that route or you're going more of the business or commercial route. And that could be any number of things. It can be marketing, it could be accounting, it could be finance, it could be all of the other aspects of business, compliance, regulatory, you name it. But those are kind of the two buckets, and there's lots of sub buckets within them, of course. But spend time reading, researching, learning whatever you can in either of those buckets that you choose, so that when you interview for a company or reach out to a company, you know something about it and you can immediately start adding value. And if you're interviewing, whether it's for my company or any of the other thousands of companies out there in the climate tech space, offer to tackle a challenge. Say to whoever's interviewing you, say, one or two of the challenges that you or the firm are facing right now. And would you be willing to let me give you my thoughts, write up a little essay or a little report on how I would tackle that challenge?
Love it. Troy, that was really fun. I'm a big fan of your story. It's super cool what you're doing and obviously really impactful. Thanks a lot for your time.
Thank you, Dylan. Pleasure being here.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.